now that we have developed the relationships of the two special right triangles, the 30, 60, 90 and the 45, 45, 90, now we're going to look at how to use them. So let's start with this problem up here. Given this triangle, what are the remaining sides and angles? Well, I don't know. What I do know is I know some strategies. Again, we have these two triangles over here. We're going to try to match them up. So, is this a 45, 45, 90 or a 30, 60, 90? So it's a 30, 60, 90. And I'm going to draw this model right next to it in the same orientation. You'll see that it's sideways versus that one's upright. Doesn't matter. So 90, 30, and we can go ahead and start labeling it. So across from the 30 is the smallest length. Across from the 30 is my smallest length of x. Across from the hypotenuse is the longest length of 2x. And then this middle length across from the 60 is x times the square root of 3. We will use, now we're going to use this, just match them up, okay? And so far, the only thing we have is we have 10 equals 2x. Okay, I'm going to write that down a little more formally. 10 equals 2x. What does x equal? Well, I can divide by the coefficient, because 2 divided by 2 simplifies to 1. I can say 5 equals x. Awesome. Okay, so that's going to be this length right here. And that makes sense. Here's x, here's 5. These are the two matched up sides. Now, we need to figure out this side over here. This side over here is a little different. It's x times the square root of 3. Okay, so we already decided x equals 5. So I'm going to say down here it's unknown, but I know that x equals 5. So if x equals 5, x root 3 equals, well, since x is 5, there's an x right there, and just dump it right there. 5 times the square root of 3. And that's this length up here. Okay. Match them up. Match them up, match them up. Now this was fairly straightforward because here the side lengths were the nice, clean, pretty numbers. You had a 2x and an x and just a 5 root of 3. Let's mix it up again. Let's mix it up a little bit. What if I give you instead one of these lengths with a square root in it? So let's do a 45, 45, 90 that way. And how about we call this long length over here, let's make this 6. So I'm going to match it up. Now these two sides are the same. That's an isosceles triangle. So this has to be the 45, 45, 90. Something like that. That's going to be x, x, x times the square root of 2. Now I just copied the model up to here. Now using the same strategy from a minute ago, we're going to match them up. I don't know what these two sides are. That's what we are here to set out. But if I can solve for x, I can figure out those sides. So here's all I know. I know that 6 I know these two guys are equal. So let's go ahead and set that up. 6 equals x times the square root of 2. Again, I need to get x by itself. I'm going to divide by the square root of 2. Square root of 2 divided by square root of 2, this simplifies to 1. I have 6 over root 2 equals x. Yay! No! We cannot leave an irrational number in the denominator. And that would be something like a square root or pi. Turns out you can't leave imaginary numbers in the denominator too, which we'll talk about later. So how do I get rid of this guy down here? How do I get rid of this root 2? What we have to do is we have to rationalize it. Rationalize the denominator. So we're going to rationalize the denominator. To do that, it sounds tough. It's not. So 6 over root 2. Let's just leave it at that. I need to get the square root out of here. And the easiest way to get the square root out of here is multiply it by itself. Now I can do that. It's legal. So if I go root 2 and root 2, this is just 1. We just showed you it's 1 here. This is just 1. So I'm not changing the value of anything. I'm just rearranging it a little bit. So now I'm just going to multiply straight across. I get 6 times square root of 2 over root 2 times root 2, which turns out to be root 4. I like square root of 4. It is one of our perfect squares, perfect roots. So this is going to be 6 root 2 over 2. Can I simplify that further? I can. 6 divided by 2 is 3. So my final answer is going to be 3 root 2. This here, that is the exact answer. That is the answer I am looking for, not some sort of decimal or anything like that. 3 times the square root of 2 is the exact answer. That is the proper answer to be provided. So I come back over here, that's 6, 3 root 2, 3 root 2. You are welcome to go ahead and square that and add them up, go through the Pythagorean theorem, and see if it equals 6. I assure you it does.